Hello students, in this video I will discuss first chapter of physics, class 11, name dimension of a physical quantity. The first question that comes to mind is, what is dimension? Before that, we have to know what is physical quantity. So we'll start our discussion from physical quantity. Physical quantity may be defined as a quantity that can be measured. In simple, we'll remember the keyword measurable quantity. Physical quantity means what? Measurable quantity. Any quantity that can be measured, so that is measurable quantity. Remember the keyword measurable quantity. For example, we can measure the length of this pen. Okay, so length is a physical quantity. We can measure the weight of this pen, so weight is also a physical quantity. Fine. I am talking for last 1 minute, so we can measure the time. So time is also a physical quantity. Today it is very hot. We can measure the temperature. Today's temperature is say 40 degree. It is very high. We can measure the temperature. So temperature is a physical quantity. We can measure the area of this phone. See, this is length, this is breadth. So multiply length into breadth, that will give the area of this phone. So we can measure the area. Thus area is also a physical quantity. We can measure the volume of this container, how much liquid can be held by this container. Okay, volume. So volume is also a physical quantity. Thus we can say that quantities that can be measured are called physical quantities. So length, mass, time, temperature, area, volume, etc. are the physical quantities. Now we can classify them in two groups. These physical quantities are not same type. They can be classified in two groups. What are the two groups? Now let us consider a pencil and a book. Now we can measure the length of the pencil directly. Okay, what is the length of the pencil? L. We can measure. What is the length of the book? Length of the book is L, so we can directly measure. What is the breadth of the book? Breadth of the book is B. We can measure directly. So we can measure length and breadth. But what is the area? Area of the book we cannot measure directly. What we have to do? We have to calculate area. What is the area of this book? Length into breadth. So what we have seen, we cannot measure the area directly. To know area, we have to first find length and then breadth. So area of this book depends on these two physical quantities. Okay, so this area is dependent on other quantity, length and breadth. So this quantity is dependent on other quantity. But when we measure length, so it is not dependent on any other quantity. We can easily find the length of this pencil. Okay, so this quantity is independent. It is not dependent. We can directly measure the length of this pencil. But this quantity is dependent. Area is dependent because we cannot measure the area directly. Thus, we classify physical quantity in two groups. One is independent, which is called fundamental quantity, and the other one is dependent, which is called derived quantity. Thus, physical quantity, two types: fundamental quantity, which is independent quantity, and derived quantity, which is dependent quantity, dependent on fundamental quantity. In physics, we come across with many physical quantity, infinite number, large number of physical quantities. In every topic, in every chapter, we'll have new physical quantity. Say in electricity, we have current, we have resistance, we have potential, intensity, capacitance. Okay. In thermodynamics, there is a temperature, there is a luminous intensity, etc., etc. There's so many physical quantities, but among these only there are 7 fundamental quantities. Okay, only 7 fundamental quantities. Remember, all other quantities are actually derived quantities. Okay, though there are a large number of physical quantities, but among them only 7 are the fundamental quantities, others are derived quantities. Here I have prepared a table of 7 fundamental quantities. What are the quantities? These are mass, length, time, temperature, current, amount of substance, and luminous intensity. About this, what is luminous intensity or what is amount of substance, we'll discuss later when required. Here we are only interested about the names. There are only 7 fundamental quantities. What are the units? We know the units. The units are for mass, kg, for length, meter, for time, second, temperature, we know centigrade, Celsius, okay, but the SI unit is Kelvin, current unit is ampere, amount of substance unit is mole, and luminous intensity candela. These things you got it in class 9. The new thing is a dimensional formula. Though it is a new thing, but it is very simple. To represent mass, we use a symbol. What symbol? Obviously, to represent mass, we can use the symbol m, or you can write m to the power 1. Okay? Mass. When there is nothing, it means there is 1. When you write this within the third bracket, this is called dimensional formula. So dimensional formula for mass is m, for length L, for time T. So you see, very simple. Mass, so m, length L, time T. Now for temperature, if I write T, then there will be big confusion. T, either T is time or T is temperature. So we cannot use T for temperature. From now onwards, we'll take the symbol from their units. So for temperature, we'll use the symbol K, for current A, and amount of substance mole, and luminous intensity CD. Apart from these quantities, there are 2 other quantities, okay, plane angle and solid angle. They are special quantities because these quantities have units, those are not dependent on any other unit. So their units are fundamental units, but they have no dimension. That's why I am calling these 2 quantities as special quantity. The units are fundamental unit, okay, but they have no dimension. Now I will find the dimensional formula of a derived quantity. For example, speed. Speed is distance by time. What is the dimension of distance? Say distance from Guwahati, say Ganeshguri to Khanapara, from Ganeshguri to Khanapara is 3000 meter. Okay, so meter is what? Length. For length we use the symbol L1. Okay, you don't write for distance D. Understood? For distance you don't write D. Just go to the unit. Distance, how do we measure distance? In terms of meter, and meter is a unit of length, so L1. For time we write T1. So what is the dimension of speed? This is L1 and T minus 1. So the dimensional formula for speed is L1 T minus 1. But here the power L to the power 1, the power 1, and T to the power minus 1. So minus 1, 1 and minus 1 are the dimensions. Okay, these powers are called the dimensions. Powers of the physical quantities, these are known as dimension. Thus, the dimension of physical quantity, the definition is, dimensions of a physical quantity may be defined as the powers to which the fundamental quantities have to be raised to represent that physical quantity. We can also find dimension if we know the unit. For example, unit of speed is meter per second. So for meter is length, so L1, second is time, so T1. So formula is L1 T minus 1. Okay, so I'll send a homework for you. You solve and send me to my personal number. Thank you very much.